Hello everybody, this is Dr. Looney. I'm back again with another video. This video is just a refresher of over finding the area and volume using integration. So we're going to start off by finding the area of an enclosed region. So we're only going to do the area of an enclosed region and volume, but with the volume part, we're only going to do rotations for this segment, and this is only when we're rotating about a horizontal line, and so you'll see that later in the video. So we have this enclosed region here. We have the region is enclosed by the function the square root of x and x squared. And so we want to first find the area of the enclosed region. In order to find the area of an enclosed region, I don't know if you guys remember this, we're either going to do the top function minus the bottom function or the right functions minus the left function. And so let's go ahead and look at that. Here, you can recopy these notes. You still should have them in your binders, but if not, you can recopy this. So again, when we're doing top minus function, then we're going to have a function of x, and our limits of integration is going to be from x1 to x2. And as you can see, I made a mistake on the second one because when we're doing right minus left, we're going to have a function of y. And so this should be y1 minus, we're going to integrate from y1 to y2 when we're doing right minus left. So in this example, we're going to go ahead and do both. We can see here that our top function is going to be the square root of x, and my bottom function is going to be x squared. So let's go ahead and look at that. I already found that points of intersection as well. This point of intersection is 1, 1. And of course, we have this point of intersection here, which is 0, 0. So we're going to be integrating from 0 to 1. Again, our top function is the square root of x, and our bottom function was x squared. So that's where we get the square root of x minus x squared, because it's top function minus bottom function. And then I just went ahead and rewrote x, the square root of x is x to the 1/2. And again, this is x to the 1/2 minus x squared. Then we take the antiderivative. Remember, when we take the antiderivative of these functions, that can be written as x to the n, where n is some real number. So I added 1 to 1/2, that gave me 3/2, and I'm going to multiply by the reciprocal of 3/2, so that's where I get the 2/3. And in this case, I have x to the second power, so if I add 1 to 2, that gives me 3, and the reciprocal of 3 is just 1/3. Now I need to plug in the limits of integration, so I'm first going to plug in 1. Well, 1 to any power is just 1. So I'm going to get 2/3 minus 1/3. Then when I plug in 0, that gives me 0. So I have 2/3 minus 1/3, so that just gives me 1/3. All right, and so now I'm going to also do right minus left. Now remember, we're right minus left. These are functions of y. So we're going to need to solve for x. So let's look here. So I went ahead and solved for x, because if I have y is equal to y, the square root of x, in order to get x by itself, I need to square both sides. Well, if I square the square root, that's just going to get rid of the square root. So that means x is equal to y squared. And then if I have y is equal to x squared, well, to get x by itself, I need to take the square root of both sides. So if you can see, I really get the same integral that I had here. The only thing that is different is that I have x's instead of y. So of course, when we do the antiderivative, we're still going to get 1/3. So either way, uh, we pretty much had the exact same integral. The only thing that was different, we just changed the x and the y. That's not going to happen all the time. We just got lucky in this case. So that's how to find the area between two curves. And I showed you both ways, whether if you're doing vertical uh, distances or horizontal distances. All right, and so now the last thing that we're going to talk about is going to be, we're going to be using the same enclosed region, but this time we want to find the volume of the particular shape. And so I'm going to cover some of this, so you just want to have to focus on everything right now. But remember, I told you that we're only going to talk about the volume when rotating about a horizontal line. So since we're rotating about a horizontal line, and the x-axis is a horizontal line, this works for any type of rotation about the horizontal line if the line of rotation is below the graph. So let's go back, refer back to this picture here. You can see since we're rotating about the x-axis, then the line of rotation is actually below the graph. So that's where this comes in play, where your capital R is your top function minus the line of rotation. But if you were in the case where your line of rotation was actually above, then your capital R would not be the same. Your capital R in that case would actually be the line of rotation minus your bottom function, because that would be the furthest distance away. So, and then your lowercase r would be the line of rotation minus the top function. So just know that what we're doing today only works when your line of rotation is below the region that you're rotating about. And so if the line of rotation is below the region that you're rotating, then your capital R is going to be your top function minus the line of rotation, and then your lowercase r is going to be your bottom function minus the line of rotation. So this is called the washer method. A lot of this I'm not going to say in the video just for time's sake, and some of this is just a refresher, but this is the washer method, where you are having the integration of, you're going to have pi, and then you're going to have your capital R minus your lowercase r dx or dy, depending on how you're rotating. Since we're rotating about a horizontal line, it's going to be dx. If we were rotating about a vertical line, it would be dy. So let's go ahead and look at the integration. I've already set it up. We've already talked about what the top function was. The top function was the square root of x. And so the line of rotation in this case is just the x-axis, so that's where y is equal to 0. So the square root of x minus 0 is just the square root of x. So, and I didn't write that out, but I can write it here. Capital R was equal to the square root of x minus 0. And so that's when I have capital R squared, that's just going to be equal to x. And so I have the square root of x squared, because that's my capital R, and then my lowercase r is just going to be x squared minus 0. So that's why I just have x squared. And remember, we're squaring my capital R and my lowercase r. So that's just going to give me x minus x to the fourth. My limits of integration does not change, because those are just the points where they intersect. So I'm going to, from the x is equal to 0 to x is equal to 1. And so when I take the antiderivative, this is really to the first power. So when I take the antiderivative of that, I'm going to go now to the second power. And then what's the reciprocal of 2 is 1/2. And so here I'm going to have minus 1 over 5, and this is actually x to the 5th power, because here you have x to the 4th power. So if you add 1 to 4, you actually get 5. Sorry about that. So that's x to the 5th power. And what's the reciprocal of 5? That's going to be 1 over 5. And so now everywhere I see an x, I'm first going to plug in a 1. Well, again, 1 to any power is going to be 1. So I get 1/2 times 1, which is going to be 1/2. And 1/5 times 1 is just going to be 1/5. Then when I plug in 0, I get 0. So I'm going to get 1/2 minus 1/5. I chose the common denominator to be 10. So that's going to give me here, if I multiply 5 here and here and 2 here and here, that's just going to give me 5 minus 2, and this is where I get the 3. So the answer to that is going to be 3 over 10. So this is just to show you again how to find the area between two curves, or taking a particular enclosed region and rotating it about a horizontal line. And again, this is only when the axis of rotation is below the region that you're rotating. And so there will be, follow with this. Once you complete the video, there will be about 4 to 5 questions that you will need to answer over these particular topics. Hopefully all is well with you guys. Thank you for tuning in, and we will, if you have any questions, just email me. Thank you.